Activation functions. The gates that give neural networks their power. Without them, no matter how many layers you stack, the network can only learn straight lines. Stack linear layers and you just get another straight line. 2 layers, 10 layers, 100, still linear. But add an activation function between layers, and suddenly the network can learn curves, bends, any shape. Sigmoid, the classic S-curve. It squashes any input into a range between 0 and 1. Watch the gradient arrow. At the edges, the curve is almost flat. The gradient nearly disappears. That's the vanishing gradient problem. In the middle, the gradient is strongest. Sigmoid is still used for binary classification output layers. Tanh, like sigmoid but centered at 0. Output ranges from -1 to +1. This zero centering means gradients can push both positive and negative, which helps training converge faster. But it still has the vanishing gradient problem at the extremes. ReLU, the game changer. Just max of 0 and x. For positive inputs, the gradient is always 1. No vanishing. It's dead simple to compute and trains much faster. But the left side is completely flat. Gradient 0. If a neuron's input is always negative, it dies. It stops learning forever. That's the dying ReLU problem. Leaky ReLU fixes the dead neuron problem. Instead of 0 on the left, it has a small slope, usually 0.1. That tiny leak keeps the gradient alive. The neuron can always recover. No more permanent death. Modern networks use Swish and GELU. They look like smoother versions of ReLU. The key difference: they're smooth around 0. That small dip below 0 lets slightly negative values through, which gives richer gradients and better training. GELU powers GPT, BERT, and most modern transformers. The vanishing gradient. Visualized. Sigmoid's maximum gradient is 0.25. Multiply that through 6 layers, and the signal shrinks to almost nothing. The early layers can't learn. ReLU's gradient is 1 for positive inputs. Multiply 1 6 times. It stays 1. The signal passes through unchanged. All 6 activation functions together. Sigmoid and Tanh. Smooth S-curves. Useful at output layers. ReLU, the workhorse of deep learning. Fast, simple, effective. Leaky ReLU fixes dead neurons. Swish and GELU. Modern smooth activations for transformers. Start with ReLU. Switch to GELU for transformers. That's the rule. Thanks for watching. Subscribe to Zari Gatongi for more math explained visually.